RESTful APIs are everywhere. It seems like every modern app has an API to allow other apps to interact. In this video, you'll learn how to bring your app's data and functionality into Microsoft 365 Copilot using, you guessed it, a standard REST API.
In our previous video, we showed you how to create declarative agents in Microsoft 365 and how you can interact with your API using API plugin. Now let's dive deeper and show you how to integrate your custom API into a declarative agent so that you can interact with your business data through a standard REST API.
To do that, I'll use Teams Toolkit in Visual Studio Code, but this time I'll ask Teams Toolkit to create an API as well as the declarative agent. So here we are inside of Visual Studio Code, and I'm going to create a new app. And for app type, I'm going to choose Copilot Agent and then Declarative Agent. But this time, I'm going to choose a declarative agent with an API plugin. At this point, I can choose to have Teams Toolkit create a new API, or I can upload the Swagger for an existing API, or I can start with an existing plugin. In this case, I'll select New API, which will cause Teams Toolkit to create an Azure Function app for my API to run in. Next, we get to select authentication type, and we can either go with no authentication, so we'll have an anonymous API. We can have an API key on our API, or we can use OAuth 2.0. I'll talk more about that later in the video. But for now, let's keep it simple and go with none as our authentication option. Now I get to select a language. I'm going to go with TypeScript and find a folder where I want to store my project. Now it wants a name for my project, and I'm going to call this the repairs agent because I happen to know that the scaffolded project has something to do with auto repairs. So it creates a new Visual Studio Code instance. What you'll see is that I actually have an Azure function called repairs.ts, and there's a little bit of data there, and a very simple application package. Here's the Swagger file in YAML format this time, and so all the details of the API are defined there. And there's a plugin file where everything that doesn't fit into the Swagger file but is still needed by Copilot is actually stored in there. And Robbie is going to show that in more detail in a few minutes. And then we have the declarative agent file, the same as you saw in the previous video. And this time notice that it has a couple of actions and it references the AI plugin JSON file. So let's go ahead and run this thing. I'm going to click run and debug it in Microsoft Edge. Now, through the wonders of modern video editing, I'm going to speed this up as Teams Toolkit is downloading the packages and compiling the code. And eventually it pops up a browser window so I can log in to Copilot. And once we're inside of Copilot, we should see our new declarative agent right there. And repairs agent, it's the local version. I could deploy one to Azure if I wanted. And it has just the one conversation starter, show repair records assigned to Karen Blair. She's a busy mechanic, I can tell. And it's going to come up and ask us if it's okay to call the API. So I'll say yes, and it will go and get the repairs data and render the results. And you can see there's some large images in here, and really the whole thing is working pretty well. At this point, you can start to modify the code and make it your own. I think that's pretty cool, but it's really just the start. I want to show you a more advanced example about a consulting company called Trey Research. They want to build a Copilot agent called Trey Genie to help their consultants. And they have an API that integrates with their project billing system. This system is where all the consultant, project, and billing information is kept. And Trey Genie will be a lot more useful if it can work with this data. I started this project, by the way, using the same Teams Toolkit scaffolding as the repair example I just showed. First, let me show you the API, which is implemented as a set of Azure functions. You can see in the upper right-hand corner of the screen that I'm already in the debugger, and I have a Visual Studio Code add-in called REST Client. So all I have to do is click on one of the requests. Here I'm in the /me path, and it's going to retrieve all the information about me, the current consultant, which in the unauthenticated version of the app is always Avery Howard. Notice that at the bottom of the screen, the application is logging each request as it comes in. There's also a post request, which allows consultants to bill their hours. There's also a /API/consultants path, which allows retrieving information about consultants. For instance, if we want a list of all the consultants with JavaScript skills, we can say skill equals JavaScript. And there's also a projects resource, which allows you to find projects by name or by the assigned consultant. And notice that this is a loose match, so just a partial query will work, which makes it work a lot easier for Copilot. And finally, there's a post request for adding someone to a project. So that's the API, but how do we tell Copilot about it? Rabia, you built the packaging for this project. Would you show us how it works?
Sure, it all starts with this Open API spec document, sometimes also known as a Swagger file. It will describe the APIs for the plugin, and it can be either in JSON or YAML. And here we can see, let's open up the app package and look at our Open API spec. It is in JSON, and you'll see information like server, path, operation, etc. Let's take a look at one of the operation, which is the get consultants, and let's look at this simplified diagram. Here you can see that with this operation, with this API call, you can pass optional filters like consultant name, project name, etc., and then get a response back. If you have a relevant response, then it will give you the ID and the name of the consultant, or it will throw an error. All this is translated and captured as definitions in this Open API spec document. Now this is standard. There might be a few other things that Copilot would require to process your API and bring back the response. That is defined in the plugin manifest. So here you can see, next we're going to look into the plugin manifest. In the package, this is Trey plugin.json, then the functions, that is basically the operations, the results, how it comes back, and how you have to map the response from what response you get from the API back to the user. All that is defined in here. Even the authentication aspects are captured here. You can see that they're also referring to the spec, the Open API spec document from within the plugin manifest. Finally, we have the declarative agent manifest, which if you've watched our previous video, we have deep dived into this, but here we are. So instructions will be your directive, or how you want your agent to act, what instructions to give, etc. Conversation starters, capabilities like bringing in knowledge from OneDrive and SharePoint, and also actions, which are basically your API plugins added to this agent. So this is how you would define your API plugin within the declarative agent. And then there is the manifest file, which is common to all applications and teams. And manifest file just holds everything together. It will have the Copilot extension entries, basically the declarative agent. The name here is Declarative Copilots, but this will change to Declarative Agents. It was a very recent name change. Declarative Agents were previously known as Declarative Copilots.
Okay, here we are back in Copilot. I'm going to start by opening the right flyout and selecting the Trey Genie Declarative Agent. And I'll pick one of the standard queries, what projects am I assigned to? And you can see the request for /API/me came in. And because this is the unauthenticated version of the API, I'm going to get Avery Howard's project information. I also get her adaptive card, and we'll talk more about those in a minute. If I ask for more details about one of the projects, it will pull in some of the data from the SharePoint document library in addition to what it got from the API. Now let me ask it to find consultants with TypeScript skills. And you can see that it uses the skill equals query string parameter on the /API/consultants URL path. And it finds Avery and Sanjay. Now we can call one of the post requests by asking it to assign Sanjay to a project. At this point, Copilot displays a confirmation card. Anytime you do a post request and take action through an API, you're going to see one of these cards. And you can see that it's decided on a forecast of 20 hours, and that's not really what I want. So I'll just ask Copilot in plain English to change the forecast. Copilot updates the card, and it looks good to me, so I'll confirm. Copilot confirms my action in a message and with an adaptive card. I can't help but notice these adaptive cards that appear in Copilot's responses. They really look great. Rabia, you're the queen of adaptive cards. Can you explain how this works?
Yes, adaptive cards are amazing. They are these small snippets of UI written in JSON, which will basically elevate the presentation of information in rich cards. They're platform agnostic and they can integrate easily. They're pretty lightweight, integrate easily into Microsoft 365 applications, especially giving it a very native feel. Right now, you are looking at the adaptive card we designed for Trey, especially for consultant information. So here we have the card payload, and here we have the data. And this payload can be passed into the plugin manifest. If you remember a few seconds back, a few minutes back, we saw the plugin manifest. For example, we were discussing the get consultants operation. We did have the response coming in as name, ID, etc. Here we can also pass now static template, which is where you will pass this adaptive cards payload, and then Copilot is able to get the information using your API, map it into this adaptive card, and present it as rich cards as response, which is, I think, pretty cool.
Another key aspect of API plugins is authentication. Most APIs are secured after all, and Copilot needs to securely access them on behalf of its users. API plugins can support API keys or OAuth 2.0 authentication. The details are stored in a vault inside of the Teams developer portal. You can find detailed setup instructions in the sample application, which is linked from the show notes, or in the Copilot Camp Lab, which will lead you step by step through setup with Entra ID. Teams Developer Portal will provide you with a reference ID that you can paste into your plugin.json file to connect it to Microsoft Copilot. When Copilot needs to run your plugin, if there isn't a cached token, it's actually going to ask the user to sign in. A browser pop-up will allow the user to log in to the identity provider's own login page, and an access token is returned to Copilot, which then calls the API on the user's behalf.
And if you want to get started working with API plugins, we have some good news. We've built these set of hands-on labs for you to go ahead and try out, adding a new API plugin, declarative agents, adaptive cards. All these concepts that we discussed is covered in these labs.
Thanks for watching. If you enjoyed this video, please give us a thumbs up. And please subscribe to the channel so you don't miss any of our Microsoft 365 developer videos. See you next time.